Okay, I've had a couple questions on the stoichiometry 423 lab. We haven't really talked about moles and the conversions that are related to that. So this is a really quick slideshow to kind of show you how to calculate those, and hopefully it will help. If not, you can always contact me and get help at any time. Okay, the first thing is that we're going to talk about, and we haven't, is molar mass. Okay, so to determine the number of moles of something, we have to know the molar mass, and that's the mass of 1 mole of the substance. You're probably like, well, wait a minute, what is a mole? A mole is this 6.022 times 10 to the 23rd entity, and that can be an ion, an atom, a molecule, a formula unit. It can be all kinds of different things. 1 mole is equal to this entity, and because they're equal to each other and it's a ratio, we can use this as a conversion factor, and this is actually a conversion factor that we're going to use quite a bit. If you've ever had chemistry class before, you'll be like, oh yeah, that's one of the numbers that we used. If you haven't, it's okay. We're going to get through it. Okay, the number or the mass, the molar mass, changes with the entity. It depends on if it has more mass or if it has less mass in it. Now what you guys are doing in the lab is you're looking at one element. So your entity is that atom. And so you have to look at how much does 1 mole of those atoms weigh. And to do that, you're going to look at a periodic table. Now there is one in the back of your purple book. There's one available for you on Moodle. There is a number of them available on if you Google it. So just use those numbers. We typically go to 4 significant figures. Don't go by decimal places, but 4 significant figures. So I picked aluminum. I went on there and I found that the mass, and this is the number typically at the bottom of a periodic table for aluminum, is 23.98 grams per mole. And like I said, this is from the periodic table. You can look on a periodic table and see where I got that. And so what this means is that my molar mass, or 1 mole of aluminum, is equal to this many grams. And so if I know how many grams I have, I can convert that in to moles. And so what I do is, let's say that I have 54.7 grams of aluminum, and we want to know how many moles that is. So just like what we've been doing before and how we've been setting things up before, is I'm going to put my given right here, my grams of aluminum, my 1 mole, and this is coming from the previous slide, and my 23.98 grams. Now when I do that, my grams, my grams here are going to cancel out, and these grams are going to cancel out. So I end up with just moles. I multiply across the top. I multiply across the bottom. So basically I'm taking 54.07, dividing it by 23.98, and I end up getting a value of 2.255 moles. And I went with 4 significant figures because that's how many significant figures both of my numbers have, and we were multiplying here. So this is similar to what you guys will be doing. You, on your lab, it's for lead and for sulfur. So use your periodic table and whatever number of grams you found of lead, and I think that's one of the problems that you are solving for at the beginning of this lab. Let me see real quick. Yes, that's what in question number 2, part 1, the mass that you get would be this value right here. And then this gram down here is the mass of lead from the periodic table. And then you do the same thing for sulfur. What you put in 2.3 is going to go right here, and then use your periodic table to get the value for this right here. And that will tell you the number of moles. Hopefully this helps you calculate the number of moles. I know the lab kind of has it a little bit not as straightforward. If this doesn't help, please don't hesitate to contact me, and I will see you in lab.